Good morning. How are you today? We will start with chapter 32 Electromagnetic Radiation. Girls, this chapter is very important. At the same time, it's easy, but it depends on you. How you have to memorize it and study it very well. Okay? After I finish explaining part by part, you have to go study it and memorize this part. Okay? Let's start with our lesson. Before we start, do you remember dispersion of light? We talked about it before. When light is dispersed into different colors according to their wavelength and their frequency. You remember the case? Here is it. We have white light. When white light enters a glass prism, what happens to the white light? It disperses into different colors. Why? We're going to understand exactly this point in this lesson. White light isn't just pure white light, it is made up of different colors. The light is separated into its different colors when it enters a prism. We will see this thing in our lesson. Electromagnetic spectrum. What's the meaning of electromagnetic spectrum? This is the electromagnetic spectrum. It consists of what? Electromagnetic waves. So all these we call them electromagnetic waves. When we combine them all together, what do we have? Electromagnetic spectrum. We are going to study each one by one, okay? Now girls, you have to memorize them in order. You have to memorize them in order. Okay, they always in the exam ask questions about electromagnetic spectrum and how they are arranged and so on. So, for me, I want to help you. I have a sentence. If you memorize this sentence, it will help you to know them in order. Maybe it's a funny sentence, but it will help you to memorize. You want to use it, use it. You don't want, it's up to you. You can just memorize them in order if you know how to memorize them. Let's start. The first word in the sentence is rich. Rich, the first letter of it is R. It's for radio waves. Rich men, M for microwaves. N, I for infrared. Venus, V for visible light. Use, U for ultraviolet. X-ray, it's for X-rays. Guns, G stands for gamma rays. So what is the sentence? Rich men in Venus use X-ray guns. Rich men in Venus use X-ray guns. If you memorize this sentence, you're going to remember the order of the electromagnetic spectrum. Radio wave, microwave, infrared, visible light, ultraviolet, X-ray, gamma rays. Okay? As I said, it's optional. It's up to you if you want to use it or not. Properties of electromagnetic waves. All electromagnetic waves, they are transverse waves. Do you remember transverse waves? Here are transverse waves. The waves that move up and down, and they are perpendicular to the direction of motion of the wave. Okay? So electromagnetic waves, all of them, they are transverse waves, not longitudinal waves. They exhibit interference and diffraction, so also they have interference and diffraction. In vacuum or air, all of the electromagnetic waves travel with the same speed of light. You remember speed of light? 3 times 10 to the power of 8 meter per second. In different mediums, they travel in different speeds. Now, in different mediums, when they enter the different mediums, they travel in different speeds. This can lead to a refraction, okay? So this speed for all of them is constant, for all of them 3 times 10 to the power of 8. But in different mediums, they have different speeds. They obey the wave equation. Do you remember wave equation? Speed equals frequency times wavelength. Here is it. Also, here we use this equation to find the speed of the wave, the frequency, or the wavelength. The last property that they carry energy from one place to another and can be absorbed by matter to cause heating and other effects. So what do they carry with them? The same as all energy, all waves. They carry energy from one place to another and they can be absorbed by matter. Okay? They cause heating and other effects. We're going to talk about this later in this lesson. The electromagnetic waves. Now, for sure you asked yourself why the name of the electromagnetic waves is electromagnet, electromagnetic. Look at it. What do we have? Electro, it's from electricity. Magnetic, it's from magnetism. So we have what? Yes, electromagnetic wave. The wave is a combination of traveling electric and magnetic fields. So we have two fields in this wave moving. One of them is magnetic field and the other electric field. They are moving perpendicular to each other and also perpendicular to the direction of travel. Girls, now in this lesson, I will just ask you about this part of magnet and electricity. Later on, you will understand when you take the chapter of electricity and magnetism, you will understand more about the magnetic field and the electric field. Okay? I just want you to know now that the electromagnetic wave is a combination of two fields, magnetic field, electric field, and they are perpendicular to each other and perpendicular to the direction of motion of the wave. As we said, we split electromagnetic waves into 7 basic types, but actually they are all part of one continuous spectrum. So, electromagnetic spectrum is consists of 7 electromagnetic waves. Rich men in Venus use X-ray guns. What differentiates them is their wavelength and their frequency. Look here at the bottom. What do you see? Wave, right? The wave of the radio wave is not the same as the waves for gamma rays. Look at the difference. What do we have here? Long wavelength. Here we have short wavelength. Low frequency, high frequency. So they are not the same, all of them, look. So what is the difference between each wave and the other? Is the wavelength and frequency. The one that has long wavelength, it has low frequency. The one that has short wavelength has high frequency. Because we know that when speed is constant, the relationship between frequency and wavelength is what? Inversely proportional. Good. So, when you memorize the sentence that I told you about, rich men in Venus use X-ray guns. While you are saying the sentence, while you are reading the sentence, you are increasing frequency. At the same time, you are decreasing the wavelength. Try to remember it like this, and you will not forget it. So, radio waves have the longest wavelength and the lowest frequency. Gamma rays, they have the shortest wavelength and highest frequency. The first type of electromagnetic waves we want to talk about is visible light. We will start with this one because we know so much about this part or this type of light. Visible light waves. In the electromagnetic spectrum, we can see with our own eyes only visible light, only. All other electromagnetic waves, we can't see them with our own eyes. We only see the visible light. That's why its name is what? Visible light. Also, visible light, it has what? Several colors, not only one color. What it has red, orange, yellow, green, blue, indigo, and violet. These are the lights or the colors in the visible light. Okay? They are arranged in order. Also, you have to memorize them in order. Okay? How they are arranged? From the longest wavelength, which is the red color, to the shortest wavelength, which is the violet color, violet light. Okay, so the red light has the longest wavelength, the violet light has the shortest wavelength. Okay, to make it easier for you, let's go back to this spectrum. Now we said when we move from here to here, what do we have? From longest to shortest. Here what I have red. So red, and here I have what? Violet. While you are moving to the right, so what's happening? You are decreasing the wavelength. So you are not going to forget that here is longer than the violet. And the red is the longest and the violet is the shortest. Good. Red light has the longest wavelength, 0.7 micrometer, and the lowest frequency. You have to memorize this number. Violet light has the shortest wavelength, 0.4 micrometer, and highest frequency. All colors travel with the same speed in air or vacuum, which is 3 times 10 to the power of 8 meter per second. We said that before, no need to repeat it. Visible light and the frequency. The frequency of light decides its color. Very important note. So not the wavelength decides the color of the light. It is the frequency. So each light here, the frequency of it decides the color of it. Okay? Different frequencies of light travel at different speeds through a transparent medium and so are refracted by different amounts. This explains dispersion. No need to repeat this note again. We said that when white light enters a glass prism with an angle, what happens? We will see all the colors of the white light inside the glass prism because each color will refract with a specific angle, not the same as the other angles. And the red light, what will happen to it? It will refract the least and the violet will refract the most. Okay? That's what happens. Okay? Visible light and amplitude is the amplitude. Do you remember the meaning of amplitude? It's the height of the wave. Look at this wave and look at this wave. Look, they don't have the same height. This one has high amplitude, this one has low amplitude. So if a light has high amplitude, it means that the source of light has high intensity. So high intensity gives high amplitude, so this light is brighter. Okay, so here, this wave, it means that the light here is brighter than the light of this wave. Monochromatic light. What's the meaning of monochromatic light? It's the light of one color and of one wavelength. What does it mean? Visible light consists of what? It consists of 7 colors. Okay? If I take one of them, if I take the red light alone, in this case, we say that this light is monochromatic light. Blue light alone, it is a monochromatic light because it has one color, one wavelength. Okay, so all the waves here from this red light, all of them, they have the same wavelength. Not the same as white light. In white light, I have inside it so many wavelengths because I have so many colors, so many lights here inside the white light. Okay, example for monochromatic light, you know what? Laser light. Laser light has one color, green, red, blue. Okay, this is an example of monochromatic light.